Hello guys, so this is second video for year 13 vectors, which is topic 12 and vectors in 3D. So if you haven't watched my first video, please watch. That is based on 12.1. Now here we are going to learn about 3D vectors in terms of x and y z axis, and unit vectors are representing with respect to I, j and k. Why we call it unit vectors I, j and k? Because their magnitude is unit here. So if you see here, unit vectors are I, j and k. So magnitude of I will be 1, magnitude of j will be 1, magnitude of k will be 1. That's why they are called unit vectors here. So if this is our x-axis here, and here unit vector is I, and this is our y-axis, here unit vector is j, and this is our z-axis, okay, and here unit vector is k, okay. So on this x-axis, if unit vector is I, but there is no j and k, so this we can write down 1 0 0, which is given here, okay, on x-axis. Similarly here j is there, but I and k is not there, so I is 0, k is 0 and j is there. Now for k unit vectors on z-axis, both I and j are 0, but k is there, so we can write down here 0 0 1. So for any 3D vector we can write down pi plus qj plus rk, or in a column vector we can write down p, q and r. This is our preferred form, so I will use this form to represent vector. Let's go through the questions now. Okay, let's consider this is point A. Yeah, so you need to understand this concept, and here it is given 1 5 and -2, and this is point B, and here it is given 0 -3 and 7. Okay, you need to find the position vector of A. So position vector, in short, I write down PV. PV means position vector of A. So position vector of A is always with respect to the point that is called origin. So O is origin, and origin's coordinates is 0 0 and 0, as we are discussing 3D coordinates. Okay, so if this is point A, you join OA. Oh, so position vector of A will be 1 minus 0, that is 1 minus 0, and then 5 minus 0 and -2 minus 0. So you will get the same vector, that is 1, 5 and -2. That is position vector of A. Okay, because it is with respect to O, so we can write down OA is 1, 5 and -2. Similarly, if this is B, you can join them, it is OB. So OB you can find like 0 minus 0 is 0, okay, -3 -0, that is -3, and 7 minus 0, that is 7. So here column vector is 0 -3 and 7. Okay, now if you join vector AB, right, A to B, okay, so A to B will be given by position vector of B minus position vector of A. So you can quickly remember this. It is second minus first here. So it is second, this is B, and this is A. So position vector of B minus position vector of A. So position vector of B with respect to origin is 0, -3 and 7. And position vector of A is 1, 5 and -2. Okay, when you when you take away 0 minus 1 becomes -1, -3 minus 5 becomes -8, and 7 minus becomes plus. 7 plus 2 is 9. So we got -1, -8 and 9. If you want to write as a column vector, then you can write down this way. If you don't want to write down in a column vector, then you can write down -1i, -8j and plus 9k. It's up to you, it's your choice. So you can use 3D vectors to describe movement in 3 dimensions. As I mentioned you that I, is 1, 0, 0. So you can say a movement by 1 unit in the x direction. If it is j is 0, 1 and 0, then you can say movement by 1 unit in the y direction. And if it is k, then you can say 0, 0 and 1. So a movement by 1 unit in z direction. So if a is any point, it is a question now. If a is given by 2, 4 and minus 3, and b is given -3, 2 and 4, you need to find position vector. In short, I'm writing PV. Find position vector of A and B. So please pause the video and have a go. So welcome back if you have tried. So here position vector of A and B. So as I mentioned you, position vector is always with respect to some point, and here that point will be origin. So if O is our origin and its x, y, z coordinates are 0, 0, 0, and here is a point A, okay, and it is given by 2, 4 and -3, right? So we can find position vector of A with respect to origin, right? So OA, position vector OA. OA means second minus first. So this is first and this is second. So second minus first. Position vector of A minus position vector of O. So O is origin. So position vector of A is 2, 4 and -3, and position vector of origin is 0, 0, 0. Okay, so 2 minus 0 becomes 2, 4 minus 0 becomes 4, -3 minus 0 becomes -3. So these are our position vector of OA. Similarly, if you need to find position vector of OB, so OB, let's do it here. It will be position vector of B minus position vector of O. So position vector of B is -3, 2 and 4. Position vector of origins are 0, 0 and 0. So this you can write down -3 minus 0, that is -3. So it should be -3 and it will be 2 and it will be 4. So this is position vector of OB, right? So if you do not prefer to write this vector in a column vector, so this you can write down 2i plus 4j minus 3k, and this one you can write down minus 3i plus 2j and plus 4k. Is that okay? Now, if it has been asked, find the position vector of AB. So in this case, it will be position vector of B minus position vector of A. It is always second minus first. So position vector of B is -3, 2 and 4 from here. Position vector of A is 2, 4 and -3 from here. So 2, 4 and -3. So -3 and -2 becomes -5. Then 2 and -4 becomes -2. And 4 and minus becomes plus. So it should be 7. So if you write like this, or you can write down -5i minus 2j plus 7k. Is that okay? Now let's go for one more question. So here the vector A is given 2, -3 and 5. B is given 4, -2 and 0. You need to find 4A plus B. That is our first part. So 4A is 2, -3 and 5, and B is 4, -2 and 0. So you need to multiply 4 times 2, and that is 8. Then 4 times minus 3, that is minus 12. And 4 times 5 is 20. So 8 minus 12 and 20. And then you are adding 4 minus 2 and 0. So if you add it, 8 plus 4 becomes 12. Minus 12 and minus 2 becomes minus 14. And 20 plus 0 becomes 20. So this is our column vector 12 minus 14 and 20, which is representing 4a plus b. Okay. Now second part, it is given here 2a minus 3b. So this is 2. Column vector is 2 minus 3 and 5. Then it is minus 3. B is 4 minus 2 and 0. So multiply with 2. So it should be 4. It should be minus 6. And it should be 10. And it is minus. You multiply with 3. I'm taking minus sign out. So 3 times 4 is 12. 3 times minus 2 is minus 6. And it is 0. So now if you simplify 4 minus 12. So 4 minus 12 becomes minus 8. This minus and minus becomes plus. So minus 6 plus 6 is 0. And 10 minus 0 is 10. So this is minus 8, 0 and 10. Okay. If you see, they can say, is there any relationship in these two vectors or not? Yeah. So you can say, okay, if one vector is a scalar multiple of other vector, then vectors will be parallel. If they are not, then they won't be parallel. Okay. So we'll see a couple of questions like that. Let's go for another question. So if A is 2i minus j plus 4k, and you need to find unit vector. So A, either you can say cap or hat. So unit vector is given by vector A divided by its modulus here. So this is unit vector formula. Okay. So A vector is given by 2i minus j. Okay. Let me clear this. So 2i minus j plus 4k. So it should be divided by modulus A. So modulus of A will be square root 2 square plus minus 1 square and 4 square from here. Okay. So 2 square will be 4 plus 1 and plus 16. That is root 21. So this should be divided by root 21. Also, you can write down like this: 2i over root 21 minus j over root 21 plus 4k over root 21. Either way, it is right. Okay. Let's move for another concept. Okay. So this is our x, y, z coordinates. And here is a vector A. Okay. This is vector A. And its distance from origin is modulus A. Okay. Suppose this vector A is making theta x angle with the x-axis. So this angle is theta x with x-axis. Okay. So if we draw perpendicular from here, okay, and this is x component, this is x-axis, so it is x component here. So if we use SOHCAHTOA, so this is our theta x, okay, subscript x, and this is modulus of A, this is x component. So cos theta x equal to x component divided by modulus of A. Is that okay? So if in the previous question, our unit vector was 2i minus j plus 4k divided by root 21. This was our unit vector. So what angle is theta x? If we need to find, so we can find it cos theta subscript x divided x component. So if you see, x component is here 2. Okay, so we can write down 2 divided by root 21. Okay, so theta x will be cos inverse 2 over root 21. If we find the value cos inverse 2 root 21, it will be 64.1 degree. Okay, similarly, if angle made with y-axis is theta y, then how we are going to solve that? Let's have a look. So this is our 3D coordinates x, y, z. Okay, and here is vector A. Okay, and its distance from origin is modulus A, and angle made with y-axis is theta y. So if we draw perpendicular from here, so it will look like this. Okay, this is modulus A, this is theta y, this is y component. Then we can say cos theta subscript y equal to y over modulus A. Similarly, angle made with z-axis, we can write down cos theta subscript z is z over modulus of A. Okay, nice and easy. Now, if you see here, our x component was 2. Here it is 1 with j, it is 1 here. Okay, and with the k, here it is 4. Okay, so cos theta y will be, here it is 1, so it should be, it is minus 1. So from here, minus 1 over modulus of A. Modulus of A is root 21. So that should be cos theta y. And theta y, we can find it cos inverse minus 1 over root 21. If we put this value in a calculator, it comes 102.6 degree. Okay, and the last one is cos theta z is z over root A. So here z component is 4 over root 21, that is cos theta z. So here theta z will be cos inverse 4 over root 21, and that will be 29.2 degree. Okay, let's go for questions now. So this is example 8 on page number 341. The points A and B have position vector 4i plus 2j plus 7k. So it's column vector, we can write down 4, 2 and 7. And another, this is A, yeah. And here we can write down 3, 4 and minus 1 relative to fixed origin O, and find AB. Okay, so if this is A with respect to O, so its position vector, yeah, like this, yeah. So we need to find OA. OA is 4, 2 and 7. It is given here 4, 2 and 7. Yeah, so let's write down here, it is 4, 2 and 7. Then there is another vector B is given here, that is, okay, so we join O to B. Okay, and it is given 3, 4 and minus 1. So it is given 3, 4 and minus 1 as a column vector. Okay. Now, last one is AB. You join A to B. Okay. So let's write down here. OA is 4 to 7. OB is 3, 4 and minus 1. So AB is given by position vector of B minus position vector of A. So position vector of OB is 3, 4 and minus 1. OA is 4, 2 and 7. So once you minus it, you get minus 1, 2 and minus 8. Okay. Now you need to find modulus of AB vector here, because we want length, modulus of AB. So modulus of AB will be minus 1 square plus 2 square and plus 8 square, and once we simplify it, it will be root 69. Similarly, we find modulus of OA. Modulus of OA will be 4 square plus 2 square plus 7 square, that will be root 69, and modulus of OB will be 3 square plus 4 square minus 1 square, that is root 26. Okay. So you need to show that triangle OAB is a isosceles. Yeah. So if you see here, two sides are same, root 69 and root 69. Length of two sides are same. So definitely this triangle is isosceles. Okay. Let's go for question number 13 on page number 342. So this is exam question. The point ABC have the position vector 8, minus 7, 4, 8, minus 3 and 3, 12, minus 6 and 3 respectively. Find the vector AB, AC and BC. Yeah. So these are the position vector with respect to origin. Yeah. These are the position vector with respect to origin. So let's find what is OA. OA is 8 minus 7 and 4. Let's write down 8 minus 7 and 4. Then we can write down OB, position vector of B, that is OB 8 minus 3 and 3, and position vector of C is 12 minus 6 and 3. Okay. Now first we need to find position vector of AB. So to find position vector of AB means position vector of B minus position vector of A. Okay. So position vector of B is 8 minus 3 and it is 3. Then minus position vector of A 8 minus 7 and 4. So if we simplify it, it will be 0, 4 and minus 1. Similarly, we can find position vector of AC. So AC, position vector of C minus position vector of A. So position vector of C is 12 minus 6 and 3 minus position vector of A 8 minus 7 and 4. If we simplify, so it will be 4, it should be 1 and minus 1. Similarly, we can find position vector of BC. So position vector of C minus position vector of B. So it should be 12 minus 6 and 3. Take away 8 minus 3 and 3. And 12 take away 8 is 4. And this is minus 3 and 0. Okay. Now we need to find modulus. To find the modulus of AB will be, it should be 0 square, 0 square, 4 square and minus 1. So let's write down here 4 square plus 1 square that is root 17 from modulus of AC. So it should be 4, 1 and minus 1. So it should be 4 square plus 1 square plus 1 square. So it should be root 18. Root 18 we can write down 3 root 2. And the last one is modulus of BC. Modulus of BC is from here only 4 and minus 3, that is 4 square and minus 3 square, that should be root 25, and it is 5. Now they are saying describe triangle ABC. If you have a look closely, all these sides are different. They are not equal. So they are going to form triangle which is none of the sides are equal. So it is scalene. Okay. Scalene triangle. Right. Let's go for another exam question. Okay. In this question, A is a point 3, 4 and 8. B is a point 1, minus 2 and 5. And C is 7, minus 5 and 7. So OA we can write down 3, 4 and 8. Similarly, we can write down OB, that is 1, minus 2 and 5. And OC we can write down 7, minus 5 and 7. Okay. Now we can find AB. So AB means position vector of B minus position vector of A. So that should be 1, minus 2 and 5. And position vector of A is 3, 4 and 8. So 3, 4 and 8. So once we simplify it, it should be minus 2, minus 6 and minus 3. Similarly, we can find AC. So position vector of C, that is this, minus position vector of A. So it should be 7, minus 5 and 7. And position vector of A, 3, 4 and 8. So 7 take away 3 is 4. And this will be minus 9. And this will be minus 1. Okay. Now we need to find position vector of BC. That is position vector of C minus position vector of B. Position vector of C is 7, minus 5 and 7. Then minus 1, minus 2 and 5. So this will be 6, minus 3 and 2. Okay. Is that fine? So this you can write down minus 2i, minus 6j and minus 3k. Okay. Similarly 4i, minus 9j, minus 1k, and this one 6i, minus 3j plus 2k. Okay. Now we have got this. So we need to find modulus of AB from here. Modulus of AB. From here we'll find modulus of AC. From here modulus of BC. So modulus of AB will be minus 2 square, that is 4, minus 6 square, that is 36, and plus 9, that is root 49, and root 49 is 7. Modulus of AC, 4 square, that is 16, 9 square, that is 81, and plus 1. So it should be root 98, that is 7 root 2. Okay. Now modulus of BC will be 6 square, that is 36, plus 9 plus 4, that is root 49, and root 49 is 7. So they are definitely forming isosceles triangle because two sides are equal. Now here it is given ABC is right angle. So if it is A, it is B, and it is C. Angle B is right angle. Okay. So definitely, and AB equal to BC. So this angle will be 45 degree. This angle is also 45 degree. So angle BAC has to be 45 degree. Nice and easy. This is another exam question, 17 on page number 343. So here it is given P2Q. If you see here, it is given P2Q. So that is PQ. And then it is given Q2R. So it is Q2R. So definitely this will be P2R. Okay, so we need to find first PQ, position vector of PQ. So position vector of PQ will be P to Q, that is given 3 minus 1 and 2. So it is 3 minus 1 and 2. QR is given minus 2, 4 and 3. Minus 2, 4 and 3. Okay, so we can find modulus of PQ first. Modulus of PQ will be 3 square minus 1 square and plus 2 square. So 3 square is 9 plus 1, 10 plus 4, that is root 14. Okay, similarly we can find QR modulus because we need to find the length. To find the length we need to find modulus. So QR will be minus 2 square plus 4 square and plus 3 square. Okay, so 4 plus 16 plus 9, that is root 29. Now we don't know PR, but we know PQ vector plus QR vector will give you PR vector, right? So we can add it. PQ is 3 minus 1 and 2. QR is minus 2, 4 and 3. And if you add them, so it should be 3 minus 2 is 1 and 3 and 5. Okay, this is our PR vector. So we can find modulus of PR as well to find the length of how much it is. So to find PR, it should be square of 1, it will be 1, square of 3, it is 9, square root of 5, that is 25. So it should be root 35. Okay, now we know length, right? So we can apply cosine rule here. It is P we know, R we know, Q we know. So PR is root 35, PQ is root 14 and QR is root 29, and they're asking you to find angle PQR, that is suppose X. So we can apply cos of X here. Okay, to find the cos of X using cosine rule, root 29 square plus root 14 square minus root 35 square divided by 2 times root 29 times root 14. Okay, so this should be 29 plus 14 minus 35. If you multiply 29 times 14, okay, and times, so it should be 2 root 406. So that should be 8 over 29 plus 14, take away 35, that is 8 over 2 root 406, and that can be simplified 4 over 406. So X will be cos inverse of 4 over root 406 will be 78.54 degree. That will be your answer. So in this exercise, I have covered all the essential questions, all the important questions, and even exam questions. Hopefully it is going to help you. Thank you very much. Bye-bye.